Hello, welcome to my Tech Fun. My name is Igor and it is time for a product review. And this time it is a 3D printer, Creality Ender 3 version 2. And this box was sent to me by Banggood for a review. This will be a long video, but you have content in the description and don't worry, ads are disabled during the video. I also hate them, so I think that's fair from my side. I'm really excited about this video because the Ender 3, if you're not familiar, it is the most popular printer in the world. And with a reason, because it's very cheap and for that price you get a very decent 3D printer. And now this is improved version 2. This will not be comparison between one or two versions. I will talk about advantages of the version 2 when I will talk about the specifications. But this video is mostly about a guide for those who want to buy the first 3D printer, because I definitely recommend this printer if you want to enter into 3D printing world. Let's see the specifications now. I'm now on Banggood's website, and most important information about some 3D printer is its printing size. So this one is 220 by 220 by 250 millimeters. It has new TMC 2208 stepper drivers, which will result ultra silent printing. I think this is the most important improvement compared to the V1, because those stepper motors resulted very high frequency and definitely I couldn't stay next to it for the longer time. And it has a new glass platform where the plastic will stick to it very good when it's heated up, and when it's cooled down it will pop up very easily. And it has new user interface and color display. Resume printing function. It has new 40 by 40 mm aluminum extrusion on y-axis, which will give more stability during the printing. This will result less ghost effect because of the smaller vibration. And it has these tensioners, which are very useful. We can adjust the tension very easily by rotating these knobs. Smart sensor. The machine can automatically resume printing after power off or filament breakage. Very nice function, but be careful with this because of that new glass. If, for example, power is off and the heating bed cools down, it will probably pop off the printing bed. So this is useful only when the power loss is only for the short period. Very useful is this toolbox, which is very nice design improvement. And yes, this should be very fantastic. I saw some videos so far. New user interface and this color display. Okay, I will place the link so you can see the specifications online on the website. Well, let's start the unboxing. Very nice packaging in this foam, which will protect the printer. Here we have the manual and then the nozzle kit and hot end, but it's attached to the base. So this means I have to remove the complete pre-assembled base from the box. Then this is the X and E stepper motor kit, because it's already part mounted. And this is that very famous display kit with the rotating knob, spool holders, so we have lever 2, and this is Z-axis stepper motor with coupling, and here I can see some filaments, belt, limit switch, indicator knob on the other side, and this is the tensioner mentioned in the specification part. And this is the Z-axis passive block, power cable with EU plug, and this is the metal blade or spatula for removing 3D printed objects from the bed. And here we have some tools. Very nice that we have these pliers here, zip ties, Allen keys, open and wrench, and we have here some aluminum extrusions, and that's it. The box is empty. So let's move the printer and start with the assembling, but first let's see the manual. We have here some service card and thank you card from Creality. The manual is in English and Chinese. It's very useful. I assembled it based on this card. Here we have a part list, very important. And then we have 14 steps before we start with the printing. But I am still looking for something very important. And here it is. SD card with a USB holder. So let's see first what's on SD card. This is content of the SD card. Unfortunately, I check it after I finish the assembling. So first, in the root we have two G codes for testing. It's good that they are in the root because I read that the printer cannot see inside the folders. Then we have here user manual. It may be useful. The content is the same like printed version, but here you can see bigger images and you can zoom into the details, for example. Then we have software and drivers. So this is Creality Slicer, and I notice it is very similar to Cura. Then we have here some troubleshooting instructions, PDFs, several STL files for testing. And here we have operation video, which is very useful, and unfortunately I noticed it only after I finished my assembling. Before we start with the assembling steps in user manual, first always check the screws which connects the main parts of this printer, and I found even two screws which are quite loose. And if connection is not completely rigid, it may have very big effect to the printing quality. And now it is a good opportunity to check this. And now, first step, installation of Z-axis limit switch kit and Z-axis profiles. So for the first step, we will need a printer base, a Z-axis profile left and right. You can recognize the left, it has two holes near the end, side by side. We will need a Z-axis limit switch kit, and we will need M5x45 bolts, 4 pieces. A quick tip, don't take them out immediately from the bag after unboxing, because it has some stickers on it which may be useful to identify the part. For the next step, I will zoom in a little bit. So loose first these two screws. And these T-nuts goes inside the left Z-axis profile near the end. Pay attention that they are vertically aligned, not horizontally. And they must be tight when aligned with the end of the rod. For example, you can use the second one. Next step is mounting the Z-axis parallels to the base. This will go here, the left side. Now the other side, this longer, you can see here two holes, and the longer part is going up, like this, here. Be careful now, because here we have the limit switch if I put it on this side. I want to protect the limit switch, so I put this on these two extrusions. Second step, installing the Z-axis motor kit and the T-type screw. Nice protection. So for this we will need this stepper motor, the T-type screw, and M4x18. Again, very useful are these stickers on the bag. So not this one, but 18. First we need to attach this screw into the coupling. For this I have to lose this upper screw here, I don't touch the bottom screw because it is already screwed into the stepper motor shaft. Make sure it is tight, you cannot pull it out. Quick check of the bottom screw. Okay, it's tight. So what I noticed with this bracket, it's not aligned with this surface of the stepper motor. So what I did, I lose these screws and I will try to align this bracket with this surface, and then I will mount the motor. So I just press the bracket to this Allen wrench, and then I will tighten one side and same on the other side. Maybe easier method is to untighten these two screws and press the motor to the extrusion and then tighten back these two bolts. Before finally tighten these screws, try visually to align this screw with this Z-rod extrusion. Step 3 is installing pneumatic joint, XE axis kit and synchronous belt. For this we have to prepare the XE axis kit, the X-axis profile. You can recognize it by the holes, or maybe it's a little bit longer than this one. Pneumatic joint. You will need two M4x16 hexagonal screws. It's always very useful to have that sticker on the bag until you finish. The synchronous belt and of course an open-end wrench. Let's place this pneumatic joint into this hole. And we have to tighten with the open-end wrench. So next step is to mount this access kit to this extrusion. And it has to go on this side where there are three holes closer to each other. The bolts go into first two holes, and the third hole is just to let this head of this bolt in this extrusion. It's a little bit tricky, but there are holes on the other side for Allen key. Before we tighten the bolts, let's make sure that top edge of the bracket is parallel with the extrusion here. Next step is to place the belt into the extrusion slot with it down, around the pulley and going back to the slot, and we are finished with third step. Step 4 is installing the nozzle kit, the Z-axis passive block. For this we will need a nozzle kit, Z-axis passive block and one M4x16 bolt. Let's place the nozzle kit to the X-axis extrusion. And now the Z-axis passive block, we have to screw it with this bolt here. Step 5 is installing the X-axis tensioner, so we have to prepare it. And also we will need two bolts. One is M4x16 and the other is countersunk M4x14. First let's remove this nut and remove the block of the tensioner. So according to this picture, this side goes up. So let's place the belt around the pulley. And in the same position, let's place this block back. The knob. To lock it with from this side with this longer screw, and from the other side with this countersunk screw. And now we have to secure the end of these belts by placing between in this groove. Now using this knob, make some tension to the belts, but first check are they aligned correctly with the slot. Be careful, don't place too much tension to it. It's very easy to over tight this knob. You will not even notice because small force here, torque here, a lot of tensions can be on this belt. Next step is installing the X-axis to the printer. And for this, of course, you will need the prepared Z-axis with the hot end and the printer itself. So this goes into this channel on the vertical extrusion, and then the screw must go into this nut here. By rotating the screw it should go inside, and here there is it. And one more time to check the belt tension. This is the Y-axis and this is the X-axis. Step 7. Install the gantry profile and display kit. For this we will need this extrusion, the last one I think, which I didn't use, the display kit, and 4 pieces of this M5 by 25 bolts. This side goes up where the head can go inside, of course from this position. Next step is to mount the monitor display on the right side of the printer. It's very nice that it can be detached very easily. Maybe I can mount it like this and then place it back a bit easier. And here goes the cable. For mounting I will have to use these T-nuts, which goes into slot of the extrusion, and tight the bolts on the other side. Of course, pay attention that these are perpendicular to the slot. And we are at the step 8, so installing the material rack, gantry cover and indication knob. So we have to prepare the material rack, the material pipe. The profile cover I already placed on both sides earlier. And we need these 2 bolts, T-nuts and the indication knob. Now I noticed that I mounted the spool on the wrong side, because this has to go back, because here goes the filament into extruder and the hot end. And I move it closer to the end. Align these flat surfaces. I was just preparing the 9th step, the wire connection, and then I noticed a problem on the y-axis, but it's good time to remind me to check all the wheels and the wheel slots, because this may be a very big problem during the printing. I'm not sure if I skipped this step somewhere, but I checked, I couldn't find this step in the manual. So I explain you on these 3 wheels. So these are fixed, but the third one has place for this open-end wrench. So this is the third wheel from the bottom, and there you can see the place for this open-end wrench. And by turning, since it is located eccentrically, you can tighten or loose the distance between the wheels. This one is fine and every other is fine, only the y-axis I have to fix. Much better. Okay, we can continue now with the wire connection. Now we have to connect these wires to the XYZ stepper motors and also the limit switch. Bigger Z connector to the stepper motor. Smaller Z connector to the limit switch. E goes to the extruder stepper motor. X goes to the X stepper motor. And the smallest connector with the X goes to the X limit switch. Here is the limit switch, but connecting is here inside. Next step is to place the Teflon tube into pneumatic connector. Press in, push to the end, pull out and secure it with this blue clip. Before I plug in the cable, it's very important to check this switch here. So I'm in Europe, so I need 230, but if you are in the US, then you have to move this switch to 115, for example. So extremely important to check this before you plug into the power your 3D printer. And this is the holder for these cables from the hot end. Okay, it's long enough. Assembling is finished, but now it's time for bed leveling. But first let's take off these protectors. Now, very interesting. So on this side, it's some kind of like textured. The print object will stick to it very good, and when it's cooled down, it will pop off. And on the other side, it's a glass, if you want to use the glass, if you get used to it. But I'll use this one. I don't really like these clips, but I hope they are designed for this, so they should hold it correctly. Now, before I turn on the printer, I want to check one thing. When I lower the Z-axis completely, it will press this limit switch. I want to be sure that the nozzle will not touch the glass. I'm not sure if you can hear the switch. So now it's clicked, it's pressed, because here it will stop theoretically the home of this is the home of this extruder, and so later I will adjust the level with these knobs. But I'm sure now that it will not hit the glass, because here the limit switch will stop the extruder. And now first time switch on. This display is really beautiful. Several times I thought this is a touch screen, but unfortunately it's not. And now that mysterious bed leveling with Ender 3. It's not that complicated. I will explain you in 2 dimensions in a few minutes too, but first let's see the basics. Before first auto homing, don't forget to check manually will the nozzle stop before the glass when the Z limit switch is pressed, as I described a few minutes ago. Great, so now it finds the position of the limit switches, and it's approximately 3 millimeters, the nozzle from the glass. Disable stepper, and we can start the adjusting with the rotating knobs. So this is the bed leveling procedure. I'm using this paper from Creality, but basically any 80-gram copy paper will do it. So after the homing and disabling the stepper motors, you have to adjust with these knobs the position of the bed. So I have to move this knob until I feel some friction between nozzle and the paper. Then I have to move to the other side. Then move back. And I have to repeat this continuously, because if I move this one, probably this one will move too. So until I get 5 plus 1 in the center position, that paper just slightly touch the nozzle, and then the bed is leveled. I will demonstrate the bed leveling in 2 dimensions because it's easier to explain. So this is the start position. Here we have our nozzle, and this is important. The nozzle moving bed is fixed. And somewhere below the nozzle we have our printing bed, and it is somewhere out of the angle, and here we have our adjusting knobs and screws. And this is the aim. So this is the start position, this is the aim. This means the printing bed is parallel with the nozzle moving path, and the distance between nozzle and the printing bed is approximately 0.1 millimeter. So this is the final aim. One more time. So this is the start position and the aim. And I will show you the incorrect version, because I noticed that a lot of users recommend this version, to move the nozzle completely to the corner and then adjust the screw below it and see what happens. So if I adjust this screw, this is the rotation point. And here we have our paper and the perfect distance, because we have that friction between paper and the nozzle. And then we move to the other side with the nozzle again to the farthest corner, and this will be our rotation point. We will adjust the right screw and see what's happened. So we move this bed until the perfect distance here, but we ruin this distance on the other side, because this is our rotation point. The correct version is try to move the nozzle exactly above the rotating knob and the screw, because now then I will adjust this screw. This is the rotation point. Then move the nozzle to the next screw exactly above it, and now this is our rotation point. And see, the bed is almost leveled. Of course, this is only in 2 dimensions, just to illustrate you. It doesn't mean with this you can do it with the 4 steps, and it doesn't mean that the first method is completely wrong, but with that method you will need more steps to finally level the bed. For example, this is the top view of the bed, so we will start here, first, second, third, fourth step, and then again 5th, 6th, 7th, until you get the constantly correct distance in all 4 corners, and then final check here in the middle. So this is the final goal. In all 4 corners I have the same friction between paper and the nozzle, so I can feel it that it's slightly connected. And same here. Then I move the bed back. Same friction here. And same in this corner, and just quick check in the middle. Great. Our bed is now leveled, almost ready to print. Next step is to preheat the printer, and we have 2 methods. The first one is to go to prepare and preheat PETG, which has already prepared settings. And the second method is go to control temperature, nozzle temperature, and set the temperature yourself. For PETG, nozzle was heated to 200 degrees Celsius and bed to 60 degrees Celsius, and for this it was ready in 2 minutes and 10 seconds in this case. And when the temperatures are ready, we can load the filament. And I will use the PETG filament which I got in a package with the printer. So clip the end of the filament under this 45-degree angle. Press the spring on the extruder to insert the filament. Can you see? Here is the end. And there it is on the bottom of the nozzle, the filament. I raise it a little bit more so filament has more space below the nozzle. Small tip to Creality: include tweezers into package, they would be very useful. Okay, now finally let's start the printing. files on that, of course. It cannot see the SD card if it's not inside, so that's a big disadvantage. Hey, there are two files. Dog 2 hours, cat 3.5 hours. Of course, dog is the winner. After we start the printing, we have three options on the display. The first one is tune. Here we can set some printing parameters like temperatures or printing speed. The second is the pause button, and here we can temporarily stop the printing and we can resume it after some time. And the third is the stop button, and with it we can finally cancel the printing. I really like that indication knob. Here you can see the retraction of the extruder. So my first 3D printing on this machine is in progress. I will create some time lapse. And I can really confirm that those TMC stepper motor drivers are doing their jobs. It's much quieter compared to the version 1. But it's not so completely quiet, so compared, for example, to my Prusa printer. But all the noise which comes from it are from fans. So I'm sure that one of the first upgrades I will do when, in near future I hope, somebody will create some better solution to these fans. But even then, this sound is much better than compared to version 1, because those old stepper motor drivers are creating that high noise which definitely I cannot leave the printer in my working room, so to working next to it. This user interface is fantastic. This color and monitor display and the knob is reacting so perfectly, it's much better even compared to my Prusa 3D printer. I'm really missing the automatic bed leveling, but probably it cannot fit into this price range. But I will left it now for printing, and I'll be back in, I don't know, 2 hours. And it was finished in 1 hour and 9 minutes, so a little bit faster. And it's now cooling down, so I will wait the bed to cool down, and then I will see it should pop up very easily. Confirm. Oh, it's not touchable. Until I'm waiting the heat bed to cool down, so I can remove the doggy. One interesting information: this power is connected to these 4 connectors, and only this printer was connected now, and I can measure here the power consumption, and when I started it was 0.42 and now it is 0.52, so this means the power consumption for 1 hour and 9 minutes of printing for this dog was 0.1 kilowatt hours. Maybe that was interesting information. This doggy really looks good. It was printed faster than it was predicted. So I can see some stringing here where the tail is, and also here where the ears are. Here the area was very small. Probably the nozzle, the filament didn't have enough time to cool down until the next layer. But it's really good. I wouldn't say that it's equal than printed like my Prusa 3D printer, for example, Mark 3S, but the Prusa is 3 or 4 times expensive compared to this Ender 3 V2. And so far I didn't even use a computer, so now I will check what's on SD card, and I will try to create my own objects and slice them with the Cura and Prusa Slicer and compare those 2 objects. So first step is to install the Creality Slicer from the SD card. First I copy it to my computer. And after a quick installation, let's start the Creality Slicer for first time. Now this is the important part. I found only for Ender 3 Pro the profile. I didn't change anything here. And then the last pop-up, it says Cura 4.7, the newest version of Cura is available. This means this is actually the modified Cura slicer. But so far I've used this one provided on SD card. And always one of the first objects when I test new 3D printer is the calibration cube. This is 20mm calibration cube. And I will save it to the SD card. And also I want to slice it with the Prusa slicer. First I have to add the Ender 3 profile. There is no V2 yet, so I will try with this profile. Set the same material and the settings. And I will try to print this G-code prepared with the Prusa slicer. I will compare two cubes. I usually print function parts, so accuracy is very important to me. Printed it 43 minutes as predicted. So it cooled down a little bit, let's try to remove it. So this was Prusa slicer. This surface is not bad, but here you see the other cube sliced with the Creality Slicer had a much better surface. Of course, it had a different infill, but I'm talking about different settings in Slicer. Sliced with Creality Slicer, and it was printed in 38 minutes. Here they are side by side, so Creality Slicer resulted a little bit better surface, but the accuracy is similar in both cases. And my next experiment was the famous Benchy, which is a real torture for 3D printing because several things we can check here. It came out quite good. It's not perfect, so I saw better benches, but it's nothing what cannot be fixed with the post-processing. So biggest problem here is some stringing and these spots on the side surface. But otherwise I'm very happy with the result. And for this Benchy the power consumption was 0.24 kilowatt hours, and more about that in one of my future videos. And then I had to try different materials. So in my next experiment I will print PETG. I just had to replace a small knob on my tripod until it changed the color. And my first PETG printing on this Ender 3 V2. This is not perfect object for testing PETG because we cannot see possible stringing, which is the weak point of the PETG. But I will do some more testing in near future with this printer and this material. And here it is. This is Peely. Quick check of the accuracy. Oh, wow. Of course in the opposite direction, but I have to wait to cool down the bed so I can remove it. The bed is still 58 degrees Celsius and it sticks very well, so I'm sure I will not have problem with the sticking, only I will see how will it came down when it cooled down. The bed temperature is now 28 degrees Celsius. Let's see how easily it came off. Oh, without any force. Very nice solution. Perfect fitting. And next material I want to try is ASA, which requires very high printing temperatures and also a very high bed temperature. I had one failed print with ABS because of the wrapping, and ASA is better from this aspect, but otherwise it has very similar properties. This is test specimen from my inside car temperature test. I disabled the fan here and I set the bed temperature to 110 degrees Celsius. And it's not perfect, but it was finished. There is a wrapping there and there, but not big so far. I hope it will be finished. And these are my printing settings. It's hold very strongly. when it cools down it should pop up very easily. Oh, how can I remove it now? 74 degrees Celsius. Yes, I can see some wrapping here. Here definitely enclosure is needed for this material too. And now the conclusions. Here you can see the pros and the cons of this printer, and I think the most important improvement are those silent stepper motor drivers and this new user interface with color display. It is really fantastic. And very useful is the smart sensor, which you can continue the printing after power loss. But be careful with that, because if the power loss is for a longer period, this textured glass will cool down and the object may pop off from it. What I didn't like about on this printer, I'm missing automatic bed leveling, but probably that it cannot fit into this price range. But also what I didn't like is that fan noise. It has those silent stepper motor drivers, and basically all the noise you can hear it are those fans, and I'm sure that a lot of companies are working now on upgrades to replace these fans with a more silent solution. Do I recommend this printer? Of course, Ender 3 is the most popular 3D printer in the world, and with V2, with upgraded version, you cannot go wrong. Especially you want to use it in living area or in office and you want to work next to it. I'm planning several videos now regarding this Ender 3 V2. I want to test different materials, I want to measure again the power consumption and similar. So I hope you will follow me to those videos too. Until that, thank you for watching and happy printing!